Hi guys, this is a short video about FiWi Getting Started. The agenda for the video is a quick overview of what FiWi is, and then I just want to quickly show some of the physical setup. This is a very early video, hoping to take people on a bit of a journey as we develop this. This is a pretty out there idea. This is an idea that my friend Bob McMahon sort of raised, I don't know, a couple of years ago now. And we've been talking about the idea more and more and developing the idea. We've actually taken it now to quite a significant way forward. In the 5G space, they do a thing called CPRI and eCPRI, CPRI, which I forget what it stands for, but it doesn't matter. It basically means that they pull down the radio signal and then drop it over fiber and then pull it to a concentrator. And so this is a really good idea. And so I was wondering how to do it. I did a lot of research and I kind of settled on this idea that maybe we could just do PCIe over fiber. And you know, I was hunting around looking for solutions, and eventually I found it. There's a guy in Canada, up near Vancouver, and they had a solution that they were doing it for different purposes. I think like GPUs and other PCIe devices. But I said, hey Bob, maybe we could try that and see if it works. And it turned out that because Bob was working at Broadcom. He had some friends that knew about the PCIe switches that this company Anancon in Canada use, and so Bob was like, "Oh yeah, well we could totally try that." So we contacted Igor, and he's been really great to work with. We've now got some new prototypes. Igor's made some special cards for the FiWi project, and that's what I'm going to show you in this video. So we're going to cover the overview. We'll talk about my physical setup. I've got an early prototype here. It's a 4-port card. We're working on some improvements. We want to make a low profile version. We probably want to move to the QSFP and support more than 4 remote radios per card. The version I've got is a 4-port, and unfortunately it's a not a low profile, so it's a high profile, which limits like putting it in smaller machines. But anyway, it's still brilliant for testing, and I'm going to show you that using a bunch of different optics, and then I'll show you how it turns up in the Linux box. So just for some background, right? And most of you probably know this. In a traditional home network, we've got the internet connection coming in. This could be fiber, this could be cable, DSL. I don't know if anyone has DSL. Into your external firewall, or sometimes they call it a home gateway. And then typically you have a switch, or the switch is built into the firewall. So you might have 4 ports or whatever ports on your firewall. And then that switch is typically PoE, and it's powering a bunch of remote access points. Those access points are typically an SoC, right? System on chip, with Linux running. They're all discrete. They don't really talk to each other. Often there's a central management gateway. So like for Unify, there's like a controller, or it could use a cloud controller. But ultimately, these are all completely independent machines. You probably run NTP on them, and so their time is vaguely synchronized, but not synchronized with any level of precision that we need for Wi-Fi, right? Wi-Fi's got incredibly high microsecond level precision requirements that NTP doesn't even come close to. And certainly not on a slow SoC that's doing lots of other things, right? So this is the traditional setup you have. If you're unlucky, you've also got what they call mesh, right? So mesh is just between the access points. They set up a private link that they typically hide from you. And then, a packet will come into the first access point. It'll then get transmitted over the invisible backhaul link to the other one, and then the other one will send it. And so that can be slow, particularly if there's any radio interference or congestion, and not good for latency, right? I think a lot of people do that just because it's easy. You don't need the cables, but it's definitely not the fastest solution. So that's a kind of traditional network. That's the sort of network I've got in my home at the moment. And with this new FiWi that Bob sent me to experiment with, I'm going to be able to directly compare traditional solution like this one to what I'm about to describe. So the idea of FiWi is that we collapse, right? We put it all into a single machine, and we connect the radios all to the single machine via fiber. So that's why we call it Fi. Fi for fiber, fiber Wi-Fi, FiWi. Really, what these are at the end of the fibers is just a M.2 Wi-Fi NIC, right? There's lots of vendors that make these: Intel, Qualcomm, MediaTek, Broadcom, etc., etc. And they're very standard. That's what's in every every laptop. In fact, most PC cards is just a little PCIe adapter to an M2 with a PCIe holder and a little metal card. So these are very traditional cards. The only real innovation here is that because we're using the PCIe over fiber via those Anencon PLX fiber switches, we can attach the remote radios to the single point. And this brings up some really interesting ideas. So now we can perfectly synchronize these, right? Because they're all just a PCIe write away, which is very low latency. So we can actually synchronize the timestamp in all of the NICs. So all of those Wi-Fi NICs have got their own timer that's running very high accuracy because it needs to be for Wi-Fi. And we can take the time from one and set the others so they're all synchronized within microseconds. Like we're talking sub 10 microsecond differences between them, which definitely in this previous scenario where we had the multiple access points, can't even come close. And so what that means is that we can now have the beacons going out synchronized. We can have, in Wi-Fi you have to listen. Is anyone using the channel? No. Now I can send, right? And there's that randomized back off. And so with all that synchronized, that means that even, let's say we put all these radios on the same channel, those beacons would interfere with each other, right? But all the clients would be perfectly synchronized, and they'd all be backing off and listening in a synchronous way. And so now they won't be battling with each other. In a traditional sense, you can imagine they're all free running, they're not synchronized, and so then different clients talking to different access points, because they've all got different timing, are all going to be interfering and pausing and backing off and interfering with each other, right? So luckily, just with 4 radios, we're going to be able to put them on different radio frequency, right? So frequency domain, beautiful, but also we're still synchronized. So now if I've got a phone that roams from one to the next, it's still time synchronized, right? So it's kind of a wild idea. There are other advantages to this architecture. We'll talk about that in future weeks, but that's the basic concept, right? So we're pulling it all into a single machine, and we've got total control. Okay, so here are my 4 FiWi remote radio heads. These have got the MediaTek cards in them for now, but that will support any traditional or typical M.2 Wi-Fi NIC. You can see we've got the dual antennas here, and I've got the USB adapters. So this is just, supplying voltage. It's not actually doing any real USB. And for the purposes of testing, I've got 850 with multi-mode. I've got bi-die single fiber, one fiber, and and that's near 1310, up or down a little bit for each direction. And then I've got the 1310 Finisar single mode. So obviously, excuse the lab, it's just my experiment place. And then we've got my PC here, which is for development, and we can see the flashing lights, the 1310s, the single fiber, and the multi-mode. So that's the physical setup. We can see here the light that's on indicates that they're all working happily. So this is looking really nice. Okay, so here we are on my NixOS machine. This is my dev box, and it's running a pretty new kernel, and it's got some GPUs in it that I've been doing some LLM stuff with. But it's a pretty beefy box, certainly overpowered for what we need it for FiWi. And then you can see here that the devices have turned up as PCIe devices via LSPCI. Actually, if we look at so this is the PCIe switch, right? So there's a card in the machine that basically has the PCIe pins coming up into it. There's a switch, and then there are the 4 outputs which go to those optics. And then on the remote end is the radios. And so we can see those. We can also see that they turn up, and you can see here that we're using the MediaTek card at the moment. There's no reason not to support other cards, but these ones are pretty nice from the perspective that these are sort of client-side cards, so they've got fewer queues, smaller buffers, this sort of thing. And then IP link show, we can see here that they've all turned up. Now, I haven't configured them yet. That'll be in a future video, but the point is that we've got over fiber a remote set of radios, so it's pretty cool. All right, thanks. Hopefully I'll have another video for you soon with more info.